Hi everyone, welcome again. In this video, we are going to learn Guava caching. Before we start, if you are totally new to the caching, I suggest you check out the videos in the same playlist to better understand the fundamentals. And please like, comment, share, and subscribe if you haven't done so. So let's kick off the session. What is Guava? Let's start with what is Guava. Guava is a library developed and open sourced by Google. So that means since this is a library, we can use it as a dependency in POM or Gradle config file in order to use it. Now, this library contains multi-purpose utilities and one of them is caching. So there are classes in this library that we can use to implement the caching. We will soon see how to use them. Guava is a simple in-memory cache, and whatever data we store in that Guava cache is local to that instance, is local to that node. What that means is when we run a program, when we run a Java program, we know it will start a JVM, a new instance of JVM, in which that program will be executed. Now, whatever data we store in the Guava cache, it resides on that same node on the same heap memory. And so if we run another instance of that same application, it will execute, it will start a new JVM, but this instance will not have this data. And that is why we say the data that we store in the Guava caching is local to that instance. Each instance, each node has its own data set. And so this data is not shared. This is not distributed cache. This is in memory, local to that node. So in this video, we will see how to populate the cache, how to fill the data in the cache so that we can use it. Second, we will also see different eviction policies supported by Guava. All right. And then we will see listeners provided by the Guava library so that we can get the notifications whenever the items are being evicted from the cache. All right. So enough theory, let's set up the code base and see how Guava caching works. For this demo, we will set up a simple Spring Boot API. This is not a hard requirement for Guava caching, but we will go with this Spring Boot API. And if you notice, we have added a single dependency, which is Spring Web. In this application, which is going to be a very simple API, there will be a single controller with some dummy data. So we don't need to add any data specific dependencies. And in this application, we will integrate Guava caching. So let's generate the project and open it with IntelliJ. Here we have unzipped the folder. Let's open it now. And while it opens and configures the project, let's search for the Maven dependency. You can simply Google Guava Maven dependency. Go to this link. And this is the one that we need, Google Core Libraries for Java. And here we can see different versions of this library. 33 is the latest one as of now. And this is the one that we need because this is a Java application. For Android applications, you need to select this one. Copy the dependency, go to the project and open pom.xml. Add the dependency and reload the project. So this will now download the Guava libraries from the Maven repository so that we can use it in the project. The Maven setup is complete. Let's start by adding the required controllers and DAOs. To do that, we'll go to the src folder, and just before that, since the library has been downloaded, we can verify in the external libraries section. You can see here, these are the Guava libraries. These are coming from the Guava library. Okay. So let's go to the main class and we'll add all the required controllers and DAO in the same class just for the ease of navigation. We can add different classes and different packages. That's also fine. But since this is a simple project, so we'll add everything in a single class. I'll start by adding the DAO that I will copy from the previous video, which was on Caffeine. There is no change in the data, in the dummy data, so I can simply copy it. And here, as you can see, this is the data DAO. And ideally, the responsibility of DAO is to communicate with the database to fetch the real data. But in this case, we will use dummy data. There is no database involved. So you can see this is the dummy database or the dummy data set that we are going to use. This is a simple movie database. Key value pairs, the key is the first name of the director and the value is the title of movie. We have two methods, getAll, that will return all the movies with their corresponding directors, key value pairs, simple hash map. And then we have another method that will return the title of the movie by director. And we can simply modify the log messages to indicate that this is a cache miss. That means if the data is not found in the cache, in that case, the actual method of DAO will be called to fetch the data from the database, in this case, the dummy dataset. All right. So we have added the DAO. Now let's add the controller as well in the same way. So we'll create a new controller called read controller. We know how to create the controllers. This is going to be REST controller. And for now, we will add a simple method in this controller, movie by director. This is going to be an HTTP GET method. So we need to add GET mapping. Notice this is coming from Spring Framework. All right. And a path variable for the director. String director. And once we have the director, we can simply return the movie by calling the method of the DAO. Before that, let me auto var it. Private data DAO and DAO. And here we will say DAO dot movie by director will pass the director. So let's see what we are doing till now. Till now, so far we have the dependency, Guava dependency, but we are not using it. We have not created any new cache. What we did, we added a simple DAO that has dummy dataset. It has two methods. And then we added a simple controller which has a single method that will expose an endpoint, an API endpoint. The client, when it calls the endpoint, will pass the director as path variable. We are getting that variable from the path variable. And then we are simply calling the method of the DAO that will call this method. So in the logs on the console, we will see this log message that, hey, I'm calling the DAO. And then the client would see the corresponding title of the movie. Okay. So let's quickly check if this setup is working fine. To do that, we can simply run the application and check the API call. So the service is up. We can call the method now. Let's go to the browser. And this is the one, localhost colon 8080, but we need to find the right endpoint, which is /movie and name of the director. Just to verify, this is the one, /movie and name of the director. And if we hit enter, we see the value John Wick for the director Chad. We can verify this one. If we go to the dataset, we see for the director Chad, we have the title John Wick. All right. And we also see the log message from the DAO that this was a cache miss, and we are calling movie by director method on the DAO for the director Chad. All right. And if we retry the same request every time, it will go to the DAO. That means if this is a real database, we will call the real database every time when the client is calling this endpoint. And we know this is the perfect candidate of caching. We can implement a caching between this call so that if the data is found in the cache, we don't need to call the database. Now that we have decided to use the Guava cache in this flow, the question is, where do we instantiate it? How do we create the Guava cache? The thing is, in an application, we want to have a single cached copy. That means a single instance of that cache for a particular dataset, so that any component that needs the same dataset don't have to recreate the cache for the same dataset. So if there is a single cached copy, all the components who are interested in the same dataset can simply query the cache and fetch the data. So we will create, you can say, a single copy of that cache, a single instance kind of thing. And to do that, what we can do, we can have a class, let's say cache service. And as this is going to be a service, so we can use the annotation service. Now this class will expose the Guava cache, and the interested components will use this cache service to use the Guava cache. How do we create the Guava cache? To do that, we will use the class cache, and notice this is coming from Guava, com.google.common.cache. We need to provide the type parameters for key and value, which is going to be string in this case, and the name of the cache, like this. So we have an instance variable of Guava cache. How do we actually instantiate it? Again, there are multiple ways. We are going to use the simplest one probably, which is to instantiate this variable from the constructor. So let's add the constructor, and from the constructor we will initialize the Guava cache, so that when this bean is getting loaded up, the Guava cache will also be instantiated at the same time. And how do we actually instantiate the Guava cache? We use another class from the library, which is cache builder. Notice this is also coming from the Guava library. So we use the cache builder, we get a new builder, and then we call the build method. There are two build methods. One takes nothing and the second one takes the cache loader. We will use this one. We will soon see what is the purpose of cache loader. And to define the cache loader, I will simply use an anonymous inner class for now. We can also replace this with lambda, but this is a bit easier to understand. So for now, we will keep it as a simple anonymous inner class. Notice this cache loader has a single method load, which accepts a key, in this case string, and it returns a value. Right now, this method returns nothing, which is null. We will return a valid value in a bit from this method. For now, let's move on and provide a get method, a getter for this Guava cache, so that the controller or any other component can use the cache. So we will say public, like this, and from this getter method we will return the instance of the movie cache. Okay, so we have a service. This service has an instance of Guava cache. We are initializing the Guava cache with the cache loader, and then we are returning the instance of that Guava cache with the getter method, get cache. So let's suppose we have to use the Guava cache in this controller. How do we do that? We know we have a service class now. So first we can auto wire the service class, which is very simple. So we say cache service, like this. And once we have the instance of cache service, we can do something like this: get me the cache, and then we can call all the methods on the Guava cache, like get, invalidate, asmap, put, all these things. So that's how we will access the Guava cache. For now, let's say we want to call the get method to get some data from the cache. So let's do that. We say get if present and we pass it a key. We will pass the same director, like this. And let's print this value from cache. So we successfully created a service, and in this service we created the Guava cache, and we auto wire the service in the controller, and now from the controller we can call the Guava cache. So let's rerun the application and see what do we get when we call get if present by passing the director to the Guava cache. The service is up. We can go to the browser and we can call the same endpoint. For the same director we see the value John Wick, and if we check the console we see from cache null, and we also see the message from the DAO because of this call. So this is still calling DAO method, but for this log message we see the value null. All right, let's do one more thing. Let's print a log message from the load method to see when does it get called. So let's print a log message here, calling CacheLoader for this key. Let's restart the service. Service is up. Let's retry the same request, check the console, and we see from cache is null, and obviously there is no change in the output. We just added an additional message in the load method. The purpose of get if present is it will check the cache for the past key, and if it finds an existing key, existing entry in the cache, it will return the value. Otherwise it will simply return null because there is nothing in the cache for the matching key. And so we know the cache is empty right now, and obviously it will return nothing. That's why we see the value null. And if you notice, if we check the other get methods, there is this get method which accepts the key, but also a callable which is called loader. What that means, when we call the get method, we pass the key, but we also pass the callable that will fetch the data. That will fetch the data from the database. And that you can say is the manual loading. Because in this case, we are saying, hey, I'm passing this key, fetch me the data for this key. And if you don't find the data in the cache, call this loader, this callable to fetch the data. So we are explicitly loading the data. The responsibility lies with us. We can also do it in an automated way. For that, we need to make one more change in the service, which is instead of using cache, we need to use LoadingCache from the Guava. Okay. And that's it. No more change in the way we create the cache. We are still creating the cache with the help of cache builder, and we are still calling the or passing the cache loader. And one more change that we need to do, we need to change the data type of getter. All right. And if we go back to the controller, now if we check the methods, we have some new methods like get, which only accepts the key. So now if we call this method and pass it a key, the same director, and it now throws an exception. So we need to add the exception to the method signature like this. All right. And let's restart the service and check if there is any difference in the behavior of the cache. So the service is up. Let's retry the same request. But this time we don't see the value, we see an error. So let's check the console for the logs. And if we check the log messages, this time we see calling CacheLoader. That means this method was called. The load method of the CacheLoader. And here we see CacheLoader returned null for key chat because we are returning null. So what that means is this is the automated way of populating the cache. That is the role of CacheLoader. Now we can cover the role of CacheLoader. So what happens when we use the loading cache, we call the get method. And what this get method will do, it will check the cache. If it finds the entry in the cache for the passed key, it will return the data from the cache. So this is the case of cache hit. But if this is a cache miss, if it can't find the data in the cache, it needs to fetch the data because it has to return the data. And how does it do that? To fetch the data, it uses the cache loader. And because we have provided the cache loader, and this is a cache miss, so it will call the load method of this cache loader automatically. We don't need to provide that. It will call it automatically, and it will try to fetch the record, the actual record for this key from the load method. And because in this case, the default implementation is returning nothing, the null value, hence we see the exception. That's why the request failed. So what we need to do is we need to fix this. We need to return a valid value from the load method, and rest everything will be handled by Guava, the cache miss. How do we do that? We already have the DAO. So we can auto var the DAO like this, data DAO. And once we have access to the DAO method, if it is a cache miss and we have to fetch the data from the load method, we can simply call the correct method of the DAO. So in this case, DAO.movie by director, and we will pass the same key. Okay, so let's see what we did. We know the load method will be called in case of a cache miss. So in the load method, we are calling the method of the DAO to fetch the data from the database, in this case, the dummy dataset. And the load method will not only return the data, it will also cache the value. That's what we are doing here. And so from the controller, we can actually remove the DAO. We don't need it anymore. And we can replace this call like this. So when the client calls this endpoint and passes a director, we will simply pass the value to the cache. The cache will check if this is a cache hit, it will return the value. If not, it will call the load method, which will call the DAO method to fetch the value. Let's now restart the service. The service is up. Let's retry. And this time we see the correct output, John Wick. And if we check the console and we see that the cache loader was called, we see this log message, which is actually this one. And from here, the DAO was called. So we see the another log message as well. Now, the good thing is because this value is cached, so if we retry the same request repeatedly, we won't see additional log messages. Because the cache already has the data, so it will return the data without calling the load method and without calling the DAO method. And that's how we enhanced the simple code to use the Guava cache and to handle the cache misses automatically. All right. So we saw how to integrate the Guava cache. We also saw how to fetch the data, how to handle the cache misses. Next, we will see how to fetch multiple values from the cache. So far, we have only used get method, which accepts a single key. But if we notice, there are different get methods in the API, like get, this one we talked about, which accepts the callable, get all, get if present, get all present. We will focus on get all method. Get all method accepts an iterable, that means a collection. It accepts multiple keys in one go. And if we pass it multiple keys, a collection, it will fetch the corresponding values for those keys. And it returns an immutable map, that means a map for all those keys. For this demo, what we will do for now, we will simply ignore this part. Whatever client passes, we are ignoring it. We will pass it a hard coded collection, multiple values like this, list dot off, and we will pass it multiple keys. We need to change the data type because it returns an immutable map. So now when the client calls this endpoint, the passed value will be ignored. Under the hood, we are calling the Guava cache for these hard-coded keys. And in response, we expect a map. So let's start the service and test this code. The service is up. Let's make the API call. And we see the map. For Chad, the title is John Wick. For John, the title is Die Hard. Let's check the logs. Now here notice we see the log messages twice. First one is for the key Chad and the second one is for the key John. For both the keys, because these are cache misses, the cache doesn't have the data. We see the cache loader being called twice. So if we are passing multiple keys for each key, it will call the load method of the cache loader because it is a cache miss in case it is a cache miss to fetch the data from the corresponding data set. Now, how can we improve it? Can we also load multiple values in one go instead of calling load method again and again? So let's say, can we do it in a single query? If this was a real database, can we do it in a single query to load multiple values? Or do we really need to call different queries for different keys in case of cache misses? To fix that, there is another method in the cache loader that we can use, which is if we go to the generate and override methods, this one. So CacheLoader also has a method loadAll that we can use to fetch multiple values in one call. Instead of calling load method for each key, we can call the loadAll method and pass it a collection to load the missing data in one query or in one go, whatever it is. All right. First of all, let's put a log message for the debugging purposes. And we can say calling CacheLoader loadAll like this. And second, we need to call the DAO, but notice the DAO does not have any method that accepts multiple values. So we'll have to do it in a dirty way. So although we are passing the collection of keys to the loadAll method, we still need to call the DAO one by one, but that is implementation. You can change it as per the use case. In this demo, because we have a simple DAO, so we can simply fetch the keys one by one from the DAO, but that's all fine. So what we can do here, we can create a map like this. Okay. And here we can do something like this. In keys and map.put key and DAO.movie by director key. And in the end, we can simply return the map. All right. And let's restart. And the service is up. We can retry the same request. we still see the same map, but in the logs, this time we see the load all of the cache loader. So that means in a real case, in a real project, the load method will not be called for each missing key. Instead, it will simply call a single call to the load all method, and then we can change this implementation, let's say, to fetch the data in a single query from the database. That is the benefit of getAll and loadAll. All right. Next, we will cover how to implement eviction policies with Guava Cache. If you don't understand eviction, please check out this video where we have explained all about eviction policies. In a nutshell, eviction is about when the entries have to be considered as stale and when they can be evicted from the cache. So there could be a memory concern where we have to limit the memory consumed by the cache, or it could be related to the staleness so that we always report the up-to-date data. In either case, we have to evict or remove some of the entries from the cache to make room for the new dataset. And that is what eviction is all about. So Guava supports a couple of eviction policies and we will see them one by one. The first one is size-based eviction policy. In size-based eviction policy, we define a maximum size. That also means the maximum number of entries that this cache can store. And if the entries cross this threshold, some of the entries will be evicted, will be removed from the cache. And this removal is based on the LRU policy least recently used. That means, let's say if the, let me show you. We define the maximum size in case of size-based eviction policy by calling this method maximum size. So when we are creating the cache by using the cache builder, we call this additional method maximum size. Let's say we define the maximum size to be 3. That means this cache, this Guava cache can store at most 3 entries, 3 elements. So because it can only store at most 3 elements, that also means if the cache is full and we have to add one more element, if it finds a new cache miss, then it has to remove one existing entry from the cache. And that existing entry will be chosen based on the access pattern of that entry. So out of existing 3 entries, the one which has not been accessed recently will be removed to make room for the new entry. So let's see this in action. Everything remains unchanged. Let me change this one. We don't need to call getAll now. We can revert it to use the past value, which is director. And we also need to change the return type string. All right. Everything remains unchanged. We have defined the maximum size as 3. So let's restart the service and check the size-based eviction policy. So the service is up. Let's go back to the browser. First of all, we'll ask for the data for director Chad. So we get the value John Wick. And at the same time, the cache was empty, but this value will be cached now. So in the cache, we have our first entry, which is Chad. Okay. Now let's query the second director as well, George. And we see the movie title Mad Max. This was also a cache miss. So this value will also be cached. And so the second entry in the cache will be added, which is George. Notice the access order. At this time T, George is the most recently used and Chad is the least recently used out of these two. We still have one room, one space left. So we can add one more entry because the maximum size is 3. So we'll query another director. Let's say James. And here we see Terminator 2 Judgment Day. So the current state of cache is we add another entry James, then George, then Chad. Now the cache has 3 elements and it has reached the maximum size because the maximum allowed size is 3. So that means if we query a new director, it will have to add a new entry in the cache. But because the cache is full, so it will have to remove one existing entry. And based on the size eviction policy, the entry that will be removed will be decided based on the LRU policy. So if we notice the access order, Chad is the one which was the least recently used and James is the one which is the latest entry in the cache. So that means if we query a new director, Chad is the one who will be removed from the cache. So let's test this. If we pick another director which is not in the cache, let's say Quentin, and if we query Quentin now, we see the title of the movie, and if we check the console, we now see that Quentin will be added to the cache. So the current state now becomes like this, and Chad will be removed. So how do we test it? Well, if we query Chad again, because it's not in the cache anymore, it will be treated as a cache miss. And for Chad also, we will see a similar entry, a similar message on the console. So let's query Chad again and see if we can see the message on the console. So let me copy Chad and we'll query Chad again. Check the console message and we see this was treated as a cache miss. So that means it was indeed removed from the cache. So that's how size-based eviction policy works. We define a maximum size, maximum allowed entries in the cache, and the cache will have those many entries only. If we try to add a new entry, the existing entries will be removed. Let's move on and learn time-based eviction. We will see how to implement time-based eviction policies in Guava. To do that, let me clear this one. And we will also remove the maximum size because we are not going to implement size-based eviction anymore. That is done. To implement the time-based eviction, we use methods which is provided in the library, and these methods are expire after. And you see there are two methods, expire after access and expire after write. Methods are divided based on the arguments, whether they accept duration, which is the duration object, or they accept the duration in the form of time unit and the value. When we talk about expire after access method, in this policy, the entries will be considered as expired entries if they have not been accessed in the duration t that we will pass when we configure the cache. And in this access, read and write both are considered as a valid access. But in case of expire after write, the entries will be expired if they have not been written. So in this method, in this policy, only write operations are considered as a valid access. All right. So access means read and write both, but expire after write means only consider write as a valid access. Otherwise, consider that entry as a stale entry that can be evicted. So let's pick this one, expire after access, and we will pass a duration. So we say duration of seconds, 10 seconds. This now means that an entry will be expired if it has not been accessed in last 10 seconds. So let's see how that works. To do that, we'll start the service. And the service is up. Let's go to the browser, make the same request again. We see the value John Wick, and in the console, we see this was indeed a cache miss. But within 10 seconds, if we query it again, it will be a cache hit, so we won't see any additional log message on the console. But if we wait for 10 seconds and if we do not access this entry within 10 seconds, then this entry will be considered as a stale entry, as an expired entry, which will be evicted from the cache. So we will query this entry again, but after 10 seconds. Let's try to query the same entry again. And this time, if we check the console, we see this entry was evicted. So it will be considered as a cache miss. Hence, we see the log message on the console again for the same entry. So that's how time-based eviction policy works. We define the policy by using one of the methods, whether it is expire after access or expire after write. Then we pass it a duration, and that duration defines the time period which will be considered before expiring an entry. And the method defines the access pattern, whether it is read and write both or just the write operations. So in this case, because we are using expire after access, read and write both will be considered as a valid access. That's why when we queried for the key, it was a read access within 10 seconds, then it was considered as a valid entry. All right, let's move on and see how to use listeners with Guava Cache. So Guava provides a removal listener that we can use to capture the events whenever the entry is being evicted or removed from the cache. So we'll comment this one and we will now try to implement a removal listener. So you see when we are creating the cache in the builder, we have this method removal listener, and in this method we define the listener. So let's do that. We will define a new removal listener. And in this case, the type parameters would be string and string. And so we implement the method which is on removal. So this listener has a single method on removal. That means whenever the entry is being removed from the cache, this method will be called and we will have access to this removal notification. What we can do with this one, we can log some information about the event. Let's see what kind of information we have in this removal notification that we can use. So we can say notification dot get cause was evicted. We can also get the key and the value that was evicted, or we can simply call the toString method to print the event, whatever is there in the toString method. Now, how do we test it? To test the removal listener, we need to remove the entries from the cache. We can do it explicitly by invalidating the entry, or we can use the same eviction policy. So let's say we reuse the same size-based eviction, but this time we set a maximum size of 1. That means the cache can store at most 1 element. So as soon as we query another one, the existing entry will be removed and this listener will be called. Let's start the service. The service is up. Okay, let's go to the browser, make the same request for director James, and we see some activity on the logs. That's fine. That also means the cache has reached its maximum size because the maximum allowed size is 1. That means if we query another director, let's say John, then the existing entry will be removed, which is James. And if we check the console, we see John was considered as a cache miss and this entry was evicted. This is coming from the listener. The toString method of this removal notification is only printing the key and the value. We can print some more information like the cause as well. Notification dot get cause toString. Let's restart the service. By the way, you can omit the toString because when we call or when we pass the object to the system.out.println, the toString method will be called implicitly. So the service is up again and we'll retry the same request for John. This will be considered as a cache miss and will be cached. Now again, the maximum allowed size is 1. And if we query another director, the first one will be evicted. And we see this was evicted. We see the key, the value, and the cause, which was size-based eviction policy. So here we can see that this entry was removed due to this policy. This is the cause. This is the reason, size-based eviction. All right. So in this way, we can use the listener, the removal listener, to capture the removal events. It could be for the debugging purposes or the tracking purposes. There are two things that we will not cover in this video, which is refresh after write method and how to invalidate the keys using invalidate method. The reason is we covered this in the last video, which was on the caffeine. Since the implementation is exactly same, I suggest you check out the last video on the caffeine to understand how refresh method works and how to invalidate the keys. And just a hint, to use the refresh after write method, we simply need to configure the builder and provide the duration. And how do we invalidate the entry, which is simple. If you have the access to the cache instance variable, we can simply call the invalidate method. So please check out the video on the caffeine where we have covered this scenario. And the last thing that we will now cover is one more eviction policy, which is based on the weight. So we have seen the size-based eviction policy where we define the maximum size, but we can also define a maximum weight. All right. And the entries will be evicted based on their weight. How do we calculate the weight of an entry? For that, we need to use another implementation provided by the library so that the cache can identify or calculate the weights of distinct entries. And based on that implementation, it will calculate the maximum weight. And when we breach the maximum weight, some of the entries will be evicted. So let's see how do we do that. as we define the maximum size, in the same way, we can define the maximum weight. So here you see we have the method maximum weight, which takes a parameter that defines the maximum weight. Let's say we say the maximum weight allowed is 10. That means whatever implementation we give to calculate the weights of the entries, the maximum weight that will be afforded is 10. If the weight value goes beyond 10 at any point of time, the cache will evict some of the existing entries to maintain the maximum weight that has been provided. The next step is, how do we calculate the weight of the entries? We need a way to weigh the entries, and we do that by providing the implementation of a where, which is this one. So let's provide the implementation, and again the type parameters will be string and string, and we need to implement the method, which is how to weigh the entries. And as you can see, the method weigh accepts two parameters, key and value, and we can use key and value both to calculate the weight of an entry. So in this case, let's say we decided to calculate the weight based on the value. Because the data type is string, so we can do something like the weight of an entry is going to be the length of the value, because this is string, divided by 2. As simple as that. We can have a more complex logic here to calculate the weight of an entry, but for this demo, to demonstrate, we are simply using the value attribute of the entry. And since this is string, we are going to use the length. And we can have a log message here calculating the weight of key and length and the original length. All right. So that's how we are going to calculate the weight of an entry, by using the value, by calculating the length of the value and dividing it by 2. And we can replace it with lambda. So that will look something like this. So now we have a way to calculate the weight of an entry, and we have also defined the maximum size. So let's restart the service and test how this works. So the service is up. Let's go to the browser and query the first character, Chad. Check the console. And here we see the length was 9. So if we divide it by 2, the weight of this entry is going to be around 4, which is 4 integer value. And the maximum allowed weight is 10, which is within the range. So that means this is fine. Next, we'll pick another director, let's say John. And if we check the console, for John, the length is 8. That means the weight is going to be 8 divided by 2, 4. So the total weight of two entries at this point is 8. The maximum allowed weight is 10. That means if we query a new director and if the weight goes beyond the maximum weight, which is 10, one of the existing entries will be removed. So let's clear the console and query a new director. And as you can see, no matter which director, if we pick anyone, the overall weight is going to be more than 10. So we can pick Quentin. And if we query Quentin, we see the length is 19. That means the weight is going to be 19 divided by 2. And the overall weight will be greater than 10. And as soon as the overall weight breaches the maximum weight that we have defined, some of the entries will be evicted from the cache to maintain the maximum size. So as we can see in the logs, the length for Quentin was 19 divided by 2. The weight is going to be 9. And maximum allowed weight is only 10, but overall weight at this time becomes 9 plus 8, 17. So the cache will evict the existing entries to maintain the maximum allowed weight. And in this case, it evicted both the entries, both the existing entries. And you can see, because we have implemented the removal listener, that these two entries were removed due to the size-based policy. All right. Why two entries? Because the maximum's weight can only be 10. and which is the weight of this entry alone. And so it had to remove both the existing entries. So that's how weight-based eviction works. We can define a maximum weight, then we need to provide the implementation of aware to tell how to weigh the different entries. And depending on the overall weight at any time t, the cache will evict the existing entries to maintain the maximum weight. So that's pretty much it on the Guava caching. Now, before we wrap up, in the last video we covered Caffeine. Caffeine is considered a drop-in replacement of Guava cache. Caffeine is much faster and provides better performance. So unless you have a hard dependency on Guava caching, if you're looking for an in-memory cache and you are really considering Guava, I suggest you check out Caffeine as well. So that's all for now. If you have any comment, any feedback, let me know in the comment section. If you like the video, please subscribe the channel. And thanks for watching. See you in the next video.